Hi, did you ever struggle to debug a Modbus device in the field? Today we're going to talk about a few ways to simulate and connect to Modbus devices to help debug them. So we're going to use a setup with two USB to RS-45 converters. So here we have two converters connected to USB, and then the RS-45 output of the converter is just looped back one to the other. So in Modbus, you have a client and a server, and the terminology is a little bit backwards, but the client is actually like the gateway or the PLC or the HMI, and the server is actually the device like a flow meter or a sensor. And the server is actually providing data to the client, so the client sends out a request and the server responds. So in our test setup today, one of these guys will be the client and one will be the server, and this way we can simulate a complete Modbus system and get that working, and then substitute in a device for the server, and that or actually use our tools to actually simulate the device, and that way you could set up your PLC or whatever ahead of time. So I'm running on Windows today. Most of the time I use Linux, but since most controls people use Windows, I'm going to do this demo in Windows today. So the tool we're going to use is Simple IoT. So let's do a search on GitHub, Simple IoT. And we want to go to the releases. Just go for the latest release, and we want the Windows x86 64, if that's I assume most people are running 64 or x86 systems still today. So let's go ahead and download that. Okay, so we can click on Open File, go into the release, and the only thing we need is a single binary, so let's copy this file. And let's go to the C drive, make a new directory. And we'll paste it in there. Okay, so now we have Simple IoT installed. We don't have a fancy installer, so you have to download the zip file, extract it, and pull the binary out of it. This is a command line app, so we'll open up PowerShell. PowerShell. Let's go to the directory we just created, and then we can run the executable. Okay, so now it's running, and Simple IoT, you start it from a terminal, but it actually creates a website or a web server that's running on your system. So it says starting the portal on port 8118. So if we go back over to the browser, let's open up localhost 8118, and that'll open up the web interface. So we'll log in. Default user password is just admin. And we'll call this our Modbus test setup. So Simple IoT is just a tree of nodes, and these nodes represent different things. It might be users or clients. So in this case, we want to create a Modbus client, and let's call this the Modbus client. And again, the client will be like a gateway or a PLC. We'll just call it a gateway for now. So then we need to add some IOs. So let's add a coil, add address 0. And this will be address. A few other things we need to set up here. We need to tell this is a client, RTU. And let's see, we need to make sure our USB devices are turned on. So in Windows, the port is COM something, so let's look at our devices. And let's look at the serial ports. So it looks like it's COM3 and COM4, so we'll use COM3 for the client. And let's go 115, 200 baud. Most of them are actually 9600, but we'll just go fast here. Response timeout. The default is 100 milliseconds, but when a PC is simulated on a Modbus, it's not quite that fast, so we're going to bump this up to 200 milliseconds. And let's set it at the max debug level. So down at our I/O, we're going to use ID 1 and address 0. We're going to call this a coil and hit save. Okay, so now oops, I overwrote the wrong thing here. Modbus client. And let's call this the coil. Okay, so now we have a Modbus and one I/O on it. And if we go over and look at the log, let's actually bump this down to like 5,000 milliseconds for now, just so it's not scrolling so fast. So what's happening here is we send out a request and it's showing us the actual data. And then it tells us it's an end of file, so basically nothing responded to our request, so it just went out into the air and nothing happened. And let's bump the logging down a little bit here as well. Let's bump this down to like 6 and see what happens. Okay, so now it's giving us a little less noise here, so that's probably good. Okay, now we have a client. Now let's set up a server so these two can talk to each other. And to do that, I'm just going to copy this node. So I'll hit the copy. And up here at the top level, I'm going to hit paste, and we're going to say duplicate. So basically, we just duplicated this setup to save us some work. So let's set this to be the server. And we'll call this a device simulator. Change this to server. Change the port to COM4. Hit save. And now this coil, the Modbus server is going to be simulating a coil, and then the client is going to be writing and reading to that coil. So let's see, do we have everything working? COM4. Oh, we need to give it a bus device ID, so let's save that. Okay, so what's happening here is the client is sending out a request to read that coil. So this is the data it's sending out. The server receives that request and responds with this value. And then here the client actually got the value back. So the client sends the request, the server receives the request, the server responds, and then the client receives the response. So you can see that this value and this value are the same, and then the response is the same here. So at this point we can go in here and let's zoom out a little bit more. If we turn this coil on at the client or the gateway, pretty soon you'll see that coil turn on the device itself. So anyway, we can add additional IOs. Let's see, let's add a input register, add address 100. So maybe we'll just call this gallons. UNT 16 value. Let's give it a value of 556 and save. Okay, so now we have another IO, and what happens here is this is a value that's set by the device, and then the client can read it. So we'll go back up here to the client, and we'll add another IO. And let's say this is input reg at 100, ID 1, address 100. Input register. Again, we're just making sure everything matches and save it. Okay, now over on this side, you'll now see that it's doing 2 reads every time it pulls. So it's reading the coil and the input register. Yeah, let's clap some of these down so we can see things a little better. And we'll notice that we set the value to 556 on the device, and the server read it. So now let's just change the value to something else. Let's change it to 1003. So go ahead and save that. And then the next time it reads, notice the value up here changed. So with this setup, there's some interesting things we can do. Notice we're simulating both the client and the server side. So if we were struggling to, let's say we're setting up a system, but we don't have the device. Maybe it's a large, expensive, heavy flow meter that we can't put in our panel shop. We could use Simple IoT to create a Modbus server that simulates our flow meter. And that way we could hook our PLC up to it and kind of make sure everything works before we deploy the panel. If we get out in the field and for some reason the flow meter isn't responding, then we could use Simple IoT, set up a Modbus client, set up the registers we're trying to read from the device, and hook up, take our PC running Simple IoT right next to the device, hook up our RS-45 connection, and then we can watch the data coming through, and we have a little bit more visibility into what's going on. For instance, we can see is the device even responding, or if it's responding, is it giving us an error code? There's a lot we can do. So this is a demo with Modbus RTU. There's also Modbus TCP, which is Ethernet based. Again, you can do all the same things with Simple IoT. So it's a pretty flexible toolkit in that you can do both client and server. and quickly set it up for exactly what you want. So I'll make one other note. Modbus addressing is a little bit confusing. So what we do in Simple IoT is we're actually inputting the address that shows up on the wire. So a lot of addresses are specified using these coil register numbers, and typically if that's the case you have to subtract 1 from that number to get the actual address number. So this page on community.tempter.org, just search on Modbus over there, you'll see this page, and it shows how to convert between these 1,000, 10,000, 30,000, 40,000 to the actual data address that you actually see on the wire. And typically you drop this first number and subtract 1. So if you saw an address of 30,001, it would actually be address 0, and it would be an input reg. So you could do that. So it's a little bit confusing, but reach out if you have any questions. So okay, I think that's it. So that's how you use Simple IoT to simulate or communicate with Modbus devices. Thanks.